Hello friends, welcome back to another session on the operating systems. We are looking at the various types of the system calls. Under this, let's begin our journey into the system calls used for process control. So there are various system calls. Mainly the system calls useful are fork, execute, exit, wait, kill, etc. So let's see some examples. Fork is a system call that creates a copy of a process. The original process is called the parent and a copy of the process is called the child. So we have one process which creates its own copy, and that is done by calling a function fork in the process itself. The process itself will create its own copy through the call fork. So when the parent process calls a system call fork, a duplicate copy of that will be created and will become another process, which is the child process. And this child process can execute some instructions, and once the child process execution is done, it exits, and till the child exits, the parent will be waiting. So the overall situation here is, we can take an example. Say we are working on some process like Google. So when we type Google onto that, one Google page or the home page of the Google will be open. So we create another page and there again type Google, then one more Google will be opened. What does that mean is the code that creates a Google page is a one that when we run that code, it creates a page, and that page continues to wait till some other action happens, or it may be that the another process may want to use Google again, then it will be made available for that. So that's one action. Other way is when a process is doing, and if it wants multiple activities to be done simultaneously, then the main process will create multiple copies of it through the fork statement, and each child created through this fork will do some part of the work, and then when that is done, then it gets exits, and till the child exits, the parent will be waiting. So just we take an example here. So you can see that there are two codes exactly the same. So the first line is main, then PID equal to fork, then if PID equal to 0, then child process, else parent process, what child process is, what parent process is. Look on the right side, then PID is fork, PID is 0, then child process, else parent process, then child and parent process are defined. So actually what happened is we started with a parent process, and this process will uh, call first the fork statement. When it calls fork statement, then a child process is created. The exact duplicate of that will be created here. The only difference is in the parent process, the value of PID is the process ID of the child process, but the value of PID in the child process will remain 0. That means now parent can identify who the child is, but child cannot identify who created it. So the child's PID will remain 0, and parents gets a PID which is the PID of the child itself. PID means process ID. Every process will have its unique ID, and in this case the child, when child was created by calling this function fork, then it returns a PID. So if this is the parent process, then it returns PID of the child, and if it is the child process, the a 0 is returned. That means from now onwards in the parent process, the PID variable will have a value of 3, 4, 5, 6, whereas in the child process the PID variable will have a value of 0. Now the next thing is very important. So if PID is equal to 0, that means it checks itself what is PID variable I am carrying. If it is 0, that means we are referring to the child process, because child will get back a 0 to this PID variable, whereas the parent will get the ID of the child. Therefore the PID equal to 0 condition checking fails in the parent. Therefore the else statement gets activated and the parent process continues to work. But on the child side, PID will be 0 because it is a child process, its process ID will be 0. Therefore it gets into the child process and the child process continues to execute. So we can define two different processes, what parent should do and what child should do, and the parent will do defined under parent process, what child should do defined under child process, and the same copy are there, two copies are there on the memory, two processes, two codes, exact two codes, but we have data, separate data for this, separate data for this. Under this data we have a variable PID whose value is 3, 4, 5, 6 in this case, where it is referring to the parent, whereas in the data field the PID variable will have value equal to 0, which is referring to the child process. So through this what we do is we can have multiple process running. So most common application of fork statement is when we are working with a child client server process, where there is a server and initially the server will be waiting for some client to query. So when a client sends a query to the server, and if server starts answering the query, then other clients cannot be acknowledged. So to make sure that multiple clients can be acknowledged simultaneously, what actually happens is when the server program or the server process will be waiting for the query from the clients. When a query from the client comes to the server, simply server creates another copy of the server and says that you take care of this client and let me continue waiting for another client. So one client comes for a service, then the server creates copy of itself and attaches that client to this server and says that you take care of this client, and the original server continues to keep waiting for new clients coming with the query. When another client comes with the query, another copy of server is created and that another copy is attached to the second client and waits for the next one. Another third client comes, third copy is created, attached to the third client, and this continues forever. So the original server code is meant to wait for the new clients to come up, and whenever a new client comes up, just a new copy of that is created, its own copy is created and attached to the client. So that's the concept of fork, which creates its own copy and makes the code or the new copy of the which we call child to continue serving the process. So that's about the fork. That's execute, exit, wait. In this example, the example of what we are talking about here in the flow chart is the parent is not going to do anything, it just keeps waiting, and when a fork, whenever we want the process to do some action, a child is created for that, and that child will continue executing whatever is requested, and once the execution is done, it exits. Till the child exits, the parent keeps waiting. That means if a parent process is activated, then it should remain active till all the child processes created by it are active. So it should keep waiting till each and every child gets exited. Only when all child processes get exited, the parent process can exit. So it keeps waiting. So that's about the process control system calls. More details to continue. So keep watching. Thank you.